Hello, my name is Chukuma Anoruo, and I'm here to make this presentation on the variability and seasonal patterns of yoga, those optical depth from IASI satellite observation. What I have done. So here I have analyzed data using from the dust aerosol optical depth input from our IASI satellite infrared atmospheric sampling interferometer. So this IASI retrieve dust using the gamma infrared observation from the map algorithm on 1 by 1 degree grid. So MAPE is the mirror aerosol profile from gamma infrared fibers, which provides us a high resolution of the aerosol properties. So in this study, I've employed the IASI version 5.1 on ascending and descending orbits from the satellites of Hector under the GEMUSAT Polar Orbital Satellite Program. So the objectives. First is to provide day-to-day analysis, global analysis of those optical depths. I've used data from June 2022 to December 2023. But in this particular study, I focused more on the December 22 to February, focusing on the dust season and also the local dust activities of the area. And secondly, to provide a seasonal characterization of those optical data and correlate it with meteorological data, for example, the precipitation, to examine the relationship between the dust specs and the local measurements. Here in this figure, I showed the already existing studies. This figure has been modified from longer tactics, Hector 2021. They try to study the dust sources from the Napa, the Southern Arabian Peninsula, and the Central Sahara, and also the Gopi satellites, focusing on the African, the Texas theory. So here what I've added, we have modified here to put in this red arrow. Here I have shown the lake area basin from the Australia subject. This they have not really studied or have not been studied to say. So I try to modify this figure, bringing this also as a source of data. So here I have also mapped it on the longitudinal data figure, also to show it's also a contributed area of erosion. So here I want to play a movie of the aerosol optic dust aerosol optical depth started for at 550 nanometer. And then for the entire studies, so it will be interesting to see also from July 22 to June 2023, the distribution of this aerosol pattern. So here, please, the movie, you have to pay attention on aerosol distribution, dust distribution to say, aerosol particle distribution, basically emanated from the source region of the African Sahara and Central Sahara. And also here, pay attention, I have other observed study to show the basin that is from the Australian sector. Then, what I have done, I have tried to also see the spatial distribution of this dust, basically using some days as a reference. For example, in this figure, from A to F show the A to D, E, sorry, show the days from December 1 to 5. So then A is December 1, December 2, B, December 3, C, December 4, D, December 5. Here you see the day-to-day variability of aerosol distribution. For example, the December, January, February, like I said, is the winter season, and it is also the dust, dust activity season. So here shows the distribution of these dust pattern. You could see here during this December 1, source, most sources is Central Sahara here. And also you see also the Australian sector here, basically in the east, there is a high sources of aerosol and aerosol, and is basically emanating from Central Africa and the Sahara, and also from the Australian area basin. And then most of the times you see the propagation, for example, when you go to here, it is mostly in the Brazilian sector, South American sector. But here in December 2, you see that is a slight propagation uh, of this dust. Basically, you see here the projection, but also here in December 3, it is more clear that this dust is basically flowing from the east and traveling to the west. Here you see it clearly also. And then this is for the December. The second panel from if to shows December 10 to 14. Then what has happened here? You see during the second week, there is a sudden disappearance of this dust, basically from the South American sector, but you can see also the traces here in the African sector. So it's occurred, reoccurred basically during the last week, that is 20 to December 20 to 24. So you see here that is, although that is the paper gap here, but you could see basically there is no trace of this. Then here you see you have it has also started to reoccur basically towards the end of December. So maybe entering uh, January, which is also the peak season or a peak month of this dust distribution. Here you see the January season. The same repeated from A to D shows December, uh, January, sorry, 1 to 5, 1 to 5, this is for January. Then January 10, also to 14, and January 20 to 24. You see also here the distribution of these dust particles in January. And also you see very intense for the American sector. Also here, the North America is a huge appearance of this dust. And then you see here, the propagation is very, very high, striking southward, and then also you see here the appearance in general. Then in February, February seems to be a very high dust season. Then this is also for February. So for this year here, this is February 1 to 5, February 10 to 14, then February 20 to 24 for Q to Pro. Then for February 1 to 5, you see here there is a total uh, disappearance for the American sector, within the South American sector, but for the Central Sahara and also the Australia, you see a very high trace. And also here, they need like the things are also the district. These are sources of dust, global dust regions. So you see what happened is during this time or during this season, there is a high intensity of dust, and they start to propagate to also the other continents. Now, how to focus. Here, I try to map using a kilogram for the December 14, 15, and 16. Then what I have done is what I try to see what is the propagation of this dust. So using a kilogram, I try to pick what is DOED, that is the dust particles as a function of longitude and latitude. So here you see the propagation. It is traveling, drifting eastwards. So from the east, drifting westwards, we see the propagation here, and then also here you see that is a sparse distribution of this dust particle. Here you could also see some trace in December 12th, December 15th, sorry, and also here in December 16th. And then getting to the last kilogram, you see this is 2022. And for the 2023, what I have done here, I try to see for December peaking the middle of every month, 14, 15, and 16. Then for February and January 2023, it may also 14, 15, 16, and also for February 2023, it may also 14, 15, 16. Just to see, since I have tried to map the distribution of these dots. So what months is the high propagation? So you could see here in January there is a high, maybe wind, it also be the source of this distribution, but towards here you could see some traces also here, but totally disappeared with February. It would this season. Then the kilogram, so this the first one shows the kilogram eastward direction, and then the six also show the westward kilogram. You see during the west, you see there is the highest outside distribution of dust. This red star shows this is the or orange to say distribution of these dust propagated from the east and then traveling down towards the west. And also you see there is it is high also here in January, in December 22, sorry, and then in, in, in February 2023, you could also see it very high in place at this latitude here. You see here, indicating this with American distribution of the dust. Yeah, what I've done is also to show the propagation of the global index of precipitation. What have January, and because it is also a source of the precipitation, also try to also reduce this distribution of dust. So you see here for the global precipitation for January, December 1. So you see here there is a high in terms of precipitation of this season, which you could see it is a reduction of dust. But also here, also you see a clear reduction of dust, which explains that the precipitation also could be a factor that also reduces this particle. Also for the wind, I try also to show the coupled between the zonal and the meridional ones to see the propagation of this. So here you see the central Sahara, and we see this contribution of both the zonal and meridional winds particle winds. So it is also a two-street. See, this direction is blue. Yeah, this way. In conclusion, the analysis satellites has been utilized to analyze the Earth of the day-to-day basis, and the major findings show here that first, there is a strong evidence of peak thrust activity in December, with the central Sahara identified as a significant interest contribution to the dust belts. The global dust belt and the study has also established this as a dust peak season in the center of the hemisphere, with the origin of the lake here, facing the Australia. So thank you very much. It's time here and there is my moment. Thank you very much.